We've looked at the specifics of the spot foreign exchange market, so now we'll look at the interest of the forward market. A forward price is used to determine the price at which an entity is financially committed to buy one currency against another currency at a future date at a price determined at the conclusion of the contract. Of course, forward prices were initially used for commercial hedging. The forward market was created in order to determine prices for an importer or an exporter, where they could hedge future flows in a non-domestic currency. So now we're entering the world of non-conditional derivatives. Derivatives are usually divided into two main families: conditional and non-conditional derivatives. A non-conditional derivative determines today the conditions of an operation that will take place in the future. This is different from conditional derivatives, which give a right to their buyer against the payment of a premium. Like all derivatives, non-conditional derivatives involve the concept of discounting future cash flows. You have to know how to discount cash flows to bring the value back to today. Discounting is the process that transforms the value of a cash flow into its equivalent present value. The discounting process is complicated because it depends on the structure of the market that you're dealing with. So we don't discount flows in euros or dollars the same way we discount flows in sterling or Australian dollars. And discounting in money markets, that's for maturities less than 12 months, will be different from discounting with maturities of over 12 months in bond markets. So let's look at an example of discounting a cash flow which will be paid in less than 12 months. Imagine that an investor will receive a flow of 1 million euros in 6 months. What's the value of this flow today? In fact, the question we ask ourselves is, how much money could be borrowed today, knowing that you will receive this sum in the future? This implies, therefore, a loan today for a sum whose future repayment will be the exact equivalent of the flow you will receive in the future. So how much can I borrow today? Let's call this borrowed amount X. This borrowed amount will oblige me to repay the amount of X plus the interest on X. In money markets, this interest amount will be X multiplied by the 6-month interest rate multiplied by the day count basis. The interest rate is always expressed on an annual basis, and the rate is prorated to bring it back to the period in question. The day count basis for currency in euros is the actual number of days over 360. So the amount of interest will be X multiplied by the interest rate multiplied by actual over 360. Just note and beware that this day count basis is actual over 365 for a large number of money markets, including the Australian dollar, the New Zealand dollar, and the British pound. But back to our example. The amount to be repaid later will be the capital plus the interest. X plus X multiplied by the interest rate multiplied by actual over 360. And we can factor this expression to become X multiplied by 1 plus the rate multiplied by actual over 360. It's customary to call this coefficient the monetary capitalization factor, since it makes it possible to find the capitalized value of a flow in money markets. So if the amount to be discounted in the future is 1 million euros, the amount to be paid back for the investor must be 1 million euros. So we'll have 1 million equals X multiplied by 1 plus the rate multiplied by actual over 360. So we can determine X as follows. X equals 1 million divided by 1 plus the rate multiplied by actual over 360 equals 1 million multiplied by 1 divided by 1 plus the rate multiplied by actual over 360. This value is called the current value of 1 million euros to be received in 6 months. This time, the coefficient is 1 divided by 1 plus the rate multiplied by actual over 360, and this is called the discount factor. So let's use a numerical example. It's the 9th of April 2018, and we need to discount today a flow of 1 million euros, which will be paid in 6 months. The period is 183 days, with a 6-month rate of 0.33%. The current value of 1 million euros is therefore 1 million divided by 1 plus 0.33% multiplied by 183 divided by 360 equals 998,325 euros and 31 cents. If the rate had been a rate in pounds, we would have had to use a different day count basis, and the calculation would have been 1 million divided by 1 plus 0.33% multiplied by 183 divided by 365, which equals £998,348 and 21 pence. Discounting is quite straightforward in money markets. But on the other hand, in bond markets, the calculations are much more complicated because it's necessary to update each year with a different rate. However, if we know the zero coupon rates for the periods, discounting can be done using these rates, since zero coupon rates assume there is no intermediate recapitalization.